Hey there everyone, Erica here from Howie49RC. If you're a regular on the channel and want to help support me in making the videos that I do, consider becoming a member of the channel. That'd help me out a ton. Anyway, I want to do a motor rebuild today on this Speed Gems Pro Cryptonite. It's a 9-turn double motor. It's in pretty good condition overall, I think. The can's a bit scratched up for sure. So is the sticker on this one side, but honestly, when that's going to be on display, you're not really going to see that side of the sticker very much, so I put up with it when I originally bought it. There's actually currently one of these motors on eBay right now that is in pristine condition, but it's like $100, a little bit more than that, and it's like, I've already got one, I don't need to, so. But the endbell is pretty dirty, lots of solder flux on it, but that's obviously not an issue. Just get that cleaned up. The brushes look like they're probably about halfway worn out, maybe a little bit more than halfway. The commutator in there looks pretty good from what I can tell. Looks like there's going to be plenty of material on there for us to turn, which is fantastic. It is missing a set of springs though, which is why I was holding off on rebuilding this one in particular. But I picked up a set of springs. There's also some screws, some brush head heat sinks, and looks like some capacitors in here as well. Not going to put the caps on because they're kind of obsolete nowadays, but we'll throw some springs on this thing. Get it all cleaned up, turn the comm, and I think that'll do the trick for this motor. With that, let's tear this thing apart, see what she looks like, and get to work. Since our brushes don't unscrew, I'm going to just go straight into pulling them out and pop the brush hoods off. Go ahead and snip our capacitors off the brush hoods real fast. And start getting the screws out and the spring posts out. I don't really need to pay super close attention to which side my spring posts are on and such because I don't have any springs on this motor right now. Thus, I don't need to keep careful track of where they go. Normally I would, but since we have brand new springs and I'm going to assume they're the same, doesn't really matter too much. Alright, we should be able to pull our brush hoods off, along with our heat sinks. Yep, oh, there's one more capacitor I need to snip off. There. And there we go. Those are filthy, 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 filthy. I'm also going to just snip these wires. I will unsolder them properly later. And there is our rather naked looking endbell. What is this? There's a little spring in there. What the hey? What is that? I'm extremely... Wait, what? Why is there a spring in the endbell? Oh, I think I see. This right here is a little itty-bitty surface mount capacitor. Looks like what they've done, in an attempt to eliminate the need for a capacitor maybe between the two brush hoods, is they've stuck a capacitor, which is what that tiny thing is right there, in between the two brush hoods with a spring to make sure that it contacts the two. That is interesting. That is so cool. I didn't even know. I don't know. I wonder if I noticed that on my Arcanite. Maybe only the ones labeled Pro have the little capacitor in them? Because some of the motors that have this label style, some of them say Pro and some of them don't. Let me grab another one real quick and see if it also has this little spring and capacitor setup. Oh, it does. It does actually have it. Okay, so right in there, in that little slot, that's the spring, which goes through and compresses the capacitor, which is tucked in that slot over there between the brush hoods. And as you can see, right there on the end bell, it says 0.1 microfarad. Huh. Now that is really cool. I pulled out my new spring set from the bag just to put them on my parts tray to keep them organized. And check this out. This is a perfect example of a stronger positive spring. You can very clearly see the difference in the amount of wraps of wire on it and just the overall size of the wire. This smaller negative spring is much, much thinner gauge wire than this positive spring. So that is exactly why you want to keep track of which sides your springs and brushes came off of. Now with all those shenanigans out of the way, we can pull our end bell off. Looks like somebody very kindly soldered the capacitors right to the screw. Are there... Hang on, when we get this off, there might be more little capacitors in there. So these motors may have built-in capacitors, so you don't actually need extra ones on the outside, like there were. Okay, I thought I heard some shims drop off in there somewhere, but I don't see them, so hopefully it's okay. We'll take a look at whatever that is, the capacitors or something, in a minute. Pull the armature out of here. Okay, there's some shims in the bottom. I'll grab momentarily. There you go. There's a close-up on that armature. Commutator looks pristine. Looks like it's been cut maybe once or twice. I can see a little bit of a lip on there, but otherwise plenty of material for us to work with here. Oh yeah, plenty of life left on this baby. Look at that. Okay, so there are indeed more little surface mount caps in the end bell. There's one right there. You can't see it, sorry. There you go, there's one of them. That was on the negative side. And there's one more right there on the positive side. Then I wonder if somehow this has like a spring mechanism to keep them applied against the brush hood. Okay, let me see if I can pop this little metal piece out of here. Yes. Okay, look at that. Man, this is so cool. Okay, so the little surface mount caps sit on top of these little L-shaped bits. As you can see, it's bent upward just a little bit to act as a spring to apply pressure to ensure contact between this metal piece and the brush hood. Or I guess the heatsink technically, but that is freaking cool right there. So I've got all the parts for our motor laid out here, and it actually has more components than most of the other motors that I work on, mainly because of the super secret squirrel caps and the super secret squirrel spring. I got all the motor components cleaned up, as you can see. The end bell in particular looks so much better. Got all that solder flux residue off of there. I hate solder flux, mainly because it makes a mess, which is why I never use solder flux ever when I solder. That's just my personal preference. Some people like it, some people don't, but speaking of solder, whoever soldered on wires to this motor last must have used some like high temp solder or something like that, or at least something that is higher temp than what I use, because I had a hell of a time getting the solder to melt, especially under the wick. Like, I couldn't get the solder to wick off at all, so I was just kind of doing the scrape and dab kind of deal, you know? So that was a little bit annoying, but it looks pretty good now. The brass brush just kind of dulled the shine on the copper hoods and heat sinks. I think the brass brush works better on the chromed hoods of the Speed Gems 2 motors and the aluminum hoods of the original Speed Gems motors, because they're chromed already and aluminum looks a little bit better brushed, and chrome isn't going to scratch. Someone in one of my previous videos mentioned to use some mother's wax polish and my Dremel with a buffing wheel on it to get these hoods and heat sinks shined up real good. I'm definitely going to do that at some point, not today because I don't have any of that polish. But with all that said, let's head back over to the electronics bench with our lathe and get this commutator turned. Alrighty, let's get our lathe all set up here. Check our armature in there. Get it all adjusted in properly. Feels about good right there. Set up my stop here, make sure that I don't go too far. Alright, yeah, so I do need to adjust my stop a little bit, because otherwise I would not be cutting enough. And looks like probably right about there should do it. Basically, I'm just setting up a limit for this direction of the cutter so I don't cut too far that way. So when I get a repeatable endpoint. So that looks good. Put our drive belts on there. I need to remember to advance my cutter super slowly this time, because the last time I cut a comm, I advanced it a little too fast and dug a groove into the commutator. So I just need to be a little more careful with that. I turn rotors at work. I'm a mechanic, right? So I turn brake rotors a lot. And the small increment on a brake lathe is a lot larger than a small increment on this lathe. So I get confused. So I just need to remember to be extra careful with this. But I think we're about ready to start here. Let's see if I need to heat this up to get it to flow. Nope, not today, nice. I've always had issues with this little bottle not actually squeezing out any oil, but it looks like today it's going to be nice. We are ready to go. It was this initial touch off last time that I dug a big groove in. Yep, there we go. Perfect. I'm going to adjust my stop a little bit because it's not cutting quite as far as I want it to. Right there is where I want it. Take a look, see how we're doing while we've got the lathe stopped. Looks like we've got a little bit going on there. Still need to do a lot over here on this side. And a lot over there too. So it looks like it was a bit out of round. Let's keep going and get it cleaned up. And that right there looks really good. I think I'm going to do one more pass just to clean it up, and then that'll be it. Look at that. Bloody perfect, if I do say so myself. Time to roll over the segments, make sure that they're nice and smooth so we don't chip our brushes. You guys know that, I say it all the time. And with the back of my X-Acto, just going to scrape out all the excess shavings. There we go. Looks like a job well done to me. Gotta give the bearings a little love, of course, too, as always. Gotta make sure they're running smooth. Feels really smooth as well. That is spinning wicked smooth. Wow. I'm impressed. Let's see if the end bell can say the same. Yeah, see, that's spinning more on the pencil than it is on the bearing itself. I should probably figure out what size bearings these are and pick some up from like Abbott or something, get some really nice high quality ones. It's like, it feels pretty smooth, but when I go to then spin it by hand, there's like some grit in there that kind of wants to stop it, it feels like. Okay, I was able to get it to spin better on a different pencil, because the normal one that I use is all worn out from having bearings put on it constantly. It's feeling a little bit better. I can still feel some grit, but I think it's working its way out. It feels pretty good now. Alright, that feels pretty good. It feels like the oil got worked in pretty good. Put lots of it on this one, so we should be good to go to assemble this motor. Alright, before we start putting our brush hoods and heat sinks on, I need to put the little capacitor spring back in place, the one that goes between the two hoods. Stick that on there like so, ever so carefully. We can put our capacitors back in. Oh wait, I think I'm putting them in sideways. Hang on. There we go. That's how they go. Oh my god, dude. Okay, there we go. They're situated on there, and I swear to God, they are probably going to fall out, but let's try and put our hoods and such on without knocking them out. Oh geez, and I need to put the freaking one in the side too. This one went upright? Yeah, it did. Ah! No! Yes. Okay. Put this side on. Okay, looks like the cap between the two hoods is in place properly. Let's go ahead and put our itty bitty little spring in there. I don't know if there's a one-way in or out for it, but it looks about right. So this guy right here is the spring that pushes on the capacitor that's on this side, and then that is the little surface mount cap that touches the bottom of the heatsink. Dudes and dudettes, I think we got it. Yeah, looks good. Oh my goodness. That is absolutely insane. Those tiny, tiny little surface mount capacitors and their little holder springs. Whew, okay. That was much more difficult than I anticipated. But now that all this is back together the way it's supposed to be, sorry to interrupt your regularly scheduled program, but I have just won an eBay auction for another brushed motor actually. Check it out. There you have it. Speed Gems 2 Sapphire. So, you guys are going to be seeing a rebuild of that here pretty darn soon, I think. Okay, back to what we were doing here, which was aligning these brush hoods. These are P94 brush hoods, which basically just means they're bigger and have more surface area of contact with the commutator. Loosen up these endbell screws a little bit. Can make sure it's all situated in there good. That moves in and out nice and smoothly. Snug down those hoods, and that should be it. These P94 hoods have their own little springs inside them to keep pressure on the brushes. Like, not against the commutator, but against the brush itself, if that makes any sense. That still slides nice and smooth. That slides right out. I know it's crazy bright, but right in there, that little piece of metal, silvery metal in there, that is a little spring that applies downward pressure on the brushes. You can see it right here. That guy is an itty bitty little spring. All that's left to do here is get the shims on the armature, get the armature put back in, put the springs on, and then I do have to solder the brushes to their hoods actually, because they are not eyelet brushes, they are solder-on. So I'll have to do that quickly, but that's not a big deal. Okay, there we go, that one's in. Put our fiber washer on the back. Endbell can go on top of there. And let's see, get that rotated around where it's supposed to be. I hear a little bit of noise in there, but there was a bunch of grit in the motor, so I suspect that that is probably what I hear. Magnets are so cool. Alright, let's get our brushes stuck in there. This one went on this side. Put our positive brush on. As I mentioned, they are different strengths, so the positive brush will likely wear out a bit faster. And because these are actually different strength springs, let me grab my Trinity spring thing and we will measure them real quick. Okay, let's start with the negative brush here. Negative brush looks like it's is flying all over the place. Looks like it was about a 4. I'm not sure if there's if it's just, you know, a reference from one to the next, the numbers on here, or if it's an actual unit of measurement. I don't think it is. I think it's just a reference, but looks like it starts moving right about 4. Let's compare it to the positive brush, which, wow, doesn't start moving until looks like 6. That's pretty crazy. That is exactly why it's a good idea to measure how strong your brushes are when you take them off of your motor, and keep track of which side they go on. Super important. I always put the little positive insignia on the end bell on my right hand side, because, you know, red on the right, and then I just arrange my parts split up in that orientation. But with that, I'm gonna go get the brushes soldered on and we can give this thing a quick test. Got my brushes soldered on. I prefer soldering them to the wire tabs instead of like the flat part of the hood. I think it just looks a little bit nicer, and you don't risk soldering your screw in, which is just a pain in the butt if you then have to go service it later. But anyways, now that we are pretty much done here, time for a quick test. Damn. Thing is going. Thing's pulling a lot of current too. There you go, guys. Motor rebuild is done. Had a lot of fun on this one, especially regarding the super secret squirrel caps. That was really cool to see how they all fit in there with the little springs and all that. It was a bit of a trick shot to get it all together for sure, but that was really cool to see for sure. I enjoyed that a lot. As per the usual, this motor ended up a lot cleaner than it started, and it looks a lot better too. This probably went from, I don't know, maybe a C- in terms of looks up to, I don't know, I'd say maybe a B+, which is a pretty good jump, all things considered. As I was working on this, I noticed that it felt like the magnets in it were stronger than some of the other motors that I've dealt with. That made me think, okay, is there such a thing as a magnet strength tester? Yes, there is, and it is called a Gauss gauge, or a Gauss meter. That might be a Gaussometer? Gauss gauge, Gauss meter, Gaussometer? Something along those lines. But I think I'm going to get one. They're not super expensive, but it would be really cool to see the different magnet strengths between motors, to see if maybe the Speed Gems Pro motors had different magnets in them than the originals or the SG2s. I think that'd be pretty cool. If you guys want me to get one, comment down below, and I will definitely consider that. I think that's all I've got to say. Like I mentioned earlier, keep an eye out for a Speed Gems 2 Sapphire motor rebuild coming soon. That should show up in the mail here in the next week or so, hopefully, and I will jump right on that for you guys. With that, thank you all so much for watching. If you did enjoy, please do leave a big fat thumbs up. If this does happen to be the first video that you have seen by me, make sure you go down, hit that subscribe button, leave a comment down below, like I said before, if you want me to get a Gauss meter. And as always, follow me on Instagram at highway49_RC, support me on Patreon, join my Discord server, and like I mentioned at the beginning of the video, if becoming a member would help me create more videos just like this one. That's all I've got to say, you guys. Thanks for sticking around, and I will see y'all in the next one.